Hey everybody, welcome back to another edition in geometry. It's Mr. Anderson here. Um, we're in section 8.5 today. We're going to talk about angles of elevation and depression. All right, so what I'm going to do today is just talk about what those two things are, and we'll work out a few examples. The actual math that we're going to be doing is exactly like what we did in section 8.4 with all the trig functions. So it's going to be the same stuff, but just kind of actually it's word problems. Don't tell anybody. Okay, so it's basically we're going to be doing some word problems today with this stuff. All right, our objectives will be to solve problems involving angles of elevation and depression, and then to use angles of elevation and depression to find the distance between two objects. All right, so first of all, what we have to talk about is angle of elevation. What does it mean? Okay, so an angle of elevation is the angle formed by a horizontal line and an observer's line of sight to an object above the horizontal line. I'll draw an example here in a second. But so remember, angle of elevation is from horizontal up to the line of sight. An angle of depression is the angle formed by a horizontal line and observer's line of sight to an object below the horizontal line. So again, from the horizontal to an angle below. So basically what it looks something maybe kind of like this. I'm going to draw some ground here. Here's like a cliff up here. Okay, here these are some cliffs, and there's somebody up here on top of the cliff, and there's somebody else down here on the bottom of the cliff, and they can look at each other. Hey, look, they're looking at each other, they can see each other. That's the line of sight. So from this person's viewpoint, if you just were to draw a horizontal line, this angle right here, that angle is your angle of elevation. So it's from the horizontal line up to the line of sight. That's the angle of elevation. Now, if you take this person on top here and you look out straight out from that, a horizontal line out from that, now in this situation, if you go from that horizontal line down to the line of sight, so this angle up here, let me see where I got some room here. This angle right here is the angle of depression. Okay, so the angle of depression is from the horizontal down to the line of sight. The angle of elevation is from the horizontal up to the line of sight. Now, one thing let me mention here before we move on. You may or may not notice anything if you've been kind of following along with all the lessons. Way back at the beginning of the year, we talked about a situation like this where if we have these two horizontal lines, they must be parallel. And the line of sight is a line that crosses or cuts through those two parallel lines. And so if you notice this angle of depression here and this angle of elevation in this example will both be exactly the same because they're alternate interior angles. Remember, alternate interior angles when we have two parallel lines and a line cuts through it. So in this same example here, both of those angles, the angle of depression and elevation in this example, are the same. So when we work out some problems here in a little bit, we're going to use that to our advantage, okay? All right, so first of all, we're at the circus. A person in the audience at ground level watches a high wire routine. A 5'6" tall acrobat is standing on a platform that is 25 feet off the ground. How far is the audience member from the base of the platform if the angle of elevation from the audience member's line of sight to the top of the acrobat is 27? Okay, in all of these situations, best thing is to go ahead and draw a little picture or a diagram, okay? Now, in this one anyway, there's one that's been drawn for us, so let's put that up. It'll save us some time. So let's kind of go through and see how we would have set this up. So first of all, it says, you know, there's a person ground level. Okay, here's the person ground level over here. They're watching a high wire routine. So here's the acrobat up here. They're on a 25-foot platform. So here's the platform up 25 feet, and we've written in here 25. and then 5'6" tall acrobat. So that's, now you notice this is 5.5 feet. Why is that? Because 6 inches is half of a foot. So this would be 5.5 feet, not 5.6. So we'll draw that in, write that amount in there. And then it says the line of where is it? Angle of elevation is 27 degrees. So the angle of elevation here from the horizontal up to here is, and that's the, it's a little confusing here because they've drawn an extra line in here that I don't think we really need. I think, let me just do this. Let's just kind of cross that out. That's, they've just drawn that in there. I don't think that's really necessary. We're not going to use that line at all. So this 27 degrees goes from here all the way up to this top line. And it says how far are they away from the platform, this audience member? Well, that's your X. Okay, so here's what we've drawn in. The platform's 25 feet. The acrobat's 5.5 feet tall, 27-degree angle of elevation, and we're trying to find X. How far away is the audience member from the platform? Okay, so first thing is, let's draw a diagram and get that all set up. Okay, now, hopefully this is going to work. Look at that. Okay, now I got some room to work here. We don't need the words anymore. We've got the drawing. And so we're just going to set this up. And we're going to say, well, one more thing I've got to do maybe to set this up based on what we have here is this. This is 25 and 5.5. So what I want to do is I want to know the height of the entire length of that triangle. So that would be what? 25 plus 5.5. So 30.5 feet. Okay, so now that we know that, now we can just set up using our trig function. Okay, so we're using 27 degrees. From 27, what side is the 30.5? Is it hypotenuse, opposite, or adjacent? Well, from 27, you know, notice here's the 90 degrees. Straight across from that is hypotenuse. So this side is hypotenuse. So we know 30.5 isn't that. And then we say, remember, adjacent means right next to. So the X is adjacent. So that means this one must be opposite. All right, so now we look at this and we say, well, the one that I know and the one that I'm trying to find are opposite and adjacent. What trig function do I use to find that? Opposite and adjacent, well, that's going to be the tangent, right? The TOA. So we're going to say the tangent of 27 equals opposite 30.5 over adjacent X. So we've set up our trig function here. Now remember, we're trying to find X. Problem is X is on the bottom, so what I have to do is get it off the bottom. How I do that is multiply by X over 1. If I do that on this side, I also have to do it on this side. So now I have X times the tangent of 27 equals 30.5. Well, X is on the top, but it's not by itself, so remember, the tangent of 27 is just a number, and so if you have any number times X, all you have to do to get rid of it is divide by that number. So we're going to divide by the tangent of 27, and then I have to do it on both sides. So now I have X equals 30.5 divided by the tangent of 27. All right, and so now, calculator. So now let's drag our calculator over here. We're just going to type this into our calculator. 30.5 divided by the tangent of 27. And it looks like there we're going to get that X, I guess I can't write until I get rid of this. I don't remember if it said to round, maybe we're going to round it to the nearest foot, I think. So that's going to be like 59.85, so that's going to round to 60 feet. So we'll round that to 60. So X would be approximately then 60 feet. Okay? So all we're doing is we're still using the trig functions. But we just have to draw a little diagram first and set it up. We're looking for triangles. We're trying to set up triangles. Okay, next one. The crossbar of a goal post is 10 feet high. If a field goal attempt is made 25 yards from the base of the goal post and it clears the goal post by 1 foot, what is the smallest angle of elevation at which the ball could have been kicked, okay, to the nearest degree? All right, I got to draw this one because I don't have a picture for this one. So here's our goal post. Don't make fun of me, by the way. Here's our goal post. Actually, that's pretty good. So here's our goal post. And so I'm going to make the goal post actually a little bit longer so I got some more room to work with here. And so here's the ground. So it said 10 feet high. Okay, so basically from the bottom of the goal post here, this is 10 feet. And of course, then here's what it also says is, oh, well, it's got to clear the goal post by 1 foot. So actually it has to go 1 foot higher. I'm going to draw this just a little bit higher here. So that's an extra foot. Kind of running out of room in there with all the drawings there. But that's an extra 1 foot up there, okay, above. And then I'm going to draw a line out here. Here's where the football is being kicked from. There's our little football. And so what else is said? It's 25 yards away. Oh, now wait a minute. This said 10 feet, and this says 25 yards. Is this going to work if we have some stuff in feet and some stuff in yards? No. We got to change it all the same thing. So if we did 10 feet and then another 1 foot, let's just change yards into feet. If we have 25 yards, how many feet is that? Well, there are 3 feet in 1 yard, so that means it's going to be 75 feet. Okay, so we'll write that in, 75 feet. This was 10 feet. And then an extra 1 up there. I don't have room to write foot. And we're trying to find out what's the angle of elevation, so that's going to be this, from the horizontal up to the line of sight, because the football's looking at the goal post, you know. All right, so there's our diagram. Okay, so that's what we have. Let me clear off the words and then we'll solve it. And so I didn't account for these not going away, but we'll work around it. All right, so just like before, remember we've got to get the whole entire length of the side of the triangle. So that's 1 foot and 10. So altogether, the whole entire length here is 11 feet. Okay? So now let's look and see what we've got. From the degree that we're trying to find, what side is the 11? And if you look at that, you go, well, that is the opposite side. 75 feet is adjacent. It's right next to it. And again, across from the 90 degrees, this is the hypotenuse. We don't need that here. On a lot of these problems, you'll find out this is the way it sets up a lot of times. And we'll end up using the same trig function, which in this case, again, if it's O and A, opposite and adjacent, again, that will be tangent. So we're going to use tangent a lot. Occasionally, you might get one where you use the hypotenuse, but you're going to use tangent a lot on these kind of problems. Okay, so let's set it up. We've got the tangent of x equals opposite, so 11, I'm going to use this, 11 over 75. Okay, so the tangent of x equals opposite 11 over 75. Well, again, now this is a little bit different because we're trying to find the measure of the angle now, right? Okay, so this works a little bit differently. Remember the inverse. We're going to have to deal with the inverse function here. So if we have the tangent of x and we're trying to get x by itself, we want to get this tangent. Basically, I want to kind of get it to the other side over here. And how I do that, remember, is the inverse tangent. So now what I have left is the measure of angle x will equal the inverse tangent of 11 over 75. And that's what I'm going to then type into my calculator. So remember, the inverse tangent is above the tangent, so I have to second function and then tangent to get it. and then 11 divided by 75. And so then it says about 8.34, and they said rounded, I think in our example they said round it to the nearest degree, and so that means that we're going to just round that to 8 degrees there. So the measure of angle X would be approximately 8 degrees. Okay? Good. All right, we're starting to get a feel for angle of elevation. So remember, elevation is from horizontal up to the line of sight. All right, angle of depression. So let's look at a few of these here and then we'll be done. Maria's at the top of a cliff and sees a seal in the water. If the cliff is 40 feet above the water and the angle of depression is 52 degrees, what's the horizontal distance from the seal to the cliff? Okay, again, we've got a little drawing here so we can look at it. Here's Maria, and it says the cliff is 40 feet high, so there's our 40 feet. It said the angle, here's where it can be a little tricky for people. It said the angle of depression is 52 degrees when she's looking down. So we draw from Maria, we draw a line out horizontally, and from the horizontal down to the line of sight, that's 52 degrees. Notice, this is 52 degrees out here, not this angle in here. A lot of times people get that mistaken, and they put the 52 degrees in here. It's out here. It's outside of our triangle. So remember what I was saying about the alternate interior angles? If this is 52 degrees here, then that means down here, this angle would be 52 degrees. And so that's why we have the 52 degrees down here. Okay? So very important there. That's a common mistake. People will write 52 degrees in here thinking this is the angle of elevation. But remember, it's from horizontal down to the line of sight. And then alternate interior angles puts this also equal to 52 down here. So the angle of depression from Maria looking down to the seal is the same as the angle of the seal, the angle of elevation of the seal looking up at Maria, if you want to think of it that way. So, and we're trying to find the distance from how far it is from the cliff basically to the seal. So that's our X. Okay. So let's work it out. We're using this 52 here. So from that, let's look at where everything is. Well, here's our 90 degrees over here. This is our hypotenuse. The 40 is opposite, and the X is adjacent. So from 52, what trig function are we going to use? We've got opposite and adjacent. That's going to be, again, tangent is opposite over adjacent. So tangent equals, the tangent of 52 equals 40 over X. Okay, so again, we got to get X back up on top. Multiply by X. So X times the tangent of 52 equals 40. And again, tangent of 52, that's just a number. So we're going to divide by that number to get it away from the X. And so what I have now is I just have the X equals 40 over the tangent of 52. And we'll just type this into our calculator. So 40 divided by the tangent of 52. And so this will be 31.25. I don't remember if they said to round that or not, but let's just round it to the nearest foot there. And so that's going to be about 31 feet. So X would be approximately equal to 31 feet. Okay? All right, we'll do one more. One more. A search and rescue team is airlifting people from the scene of a boating accident when they observe another person in need of help. If the angle of depression to this other person is 42 degrees and the helicopter is 18 feet above the water, what's the horizontal distance from the rescuers to this person, to the nearest foot? Okay, so I'm going to so there's a helicopter saving people. Like, okay, let me see what I can do. Here's the helicopter, and the blades are spinning around. You know, you got the helicopter here, maybe looking something like this. Don't make fun of me for my drawing here. Okay, there's a little person inside. And so there's the helicopter. And so here's the, you know, the water down here. There's the people down here that they're saving. So this helicopter, it says, is what, 18 feet above the water. So 18 feet. There's another person out here in the water. And they're like, hey, help, 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 help. They're over here. And the helicopter pilot can look down at this person and see them there. And so here's our horizontal distance. Here's our 90 degrees. So 18 feet up. The angle of depression is 42. So from the helicopter looking straight out, this angle is 42 degrees. Again, remember, not the one in here, the one out here. So by alternate interior angles, this 42 is the same as this angle down here. This is also 42. And we are trying to find out what's the horizontal distance. So that's the distance from here over. So this is our drawing. All right, so let's solve this. So we're starting from 42. So let's name the sides again. So here's our 90 degrees. Across from the 90 degrees is the hypotenuse. And then the other two, 18 will be opposite, x is adjacent. So if we're doing tangent, or, well, I gave it away. Okay, tangent. It's opposite over adjacent again. Big surprise. And so this will be the tangent of 42 equals 18 over x. So we go to solve that, just go times x to get the x back up on top again. X times the tangent of 42 equals 18. Divide by the tangent of 42. And so, oh, wow, that took a while to come up there, but okay. And so then we just do 18 divided by the tangent of 42. Type that into our calculator, and we're going to get it 19.99, so that's approximately 20 feet. And so we will say that x is approximately 20 feet. Okay, so there you go. A few examples of angle of elevation and angle of depression. Hope that made sense today, and hope my drawings weren't too funny for you. Anyway, thanks for being here. We'll see you again next time. Mr. Anderson saying bye.